taking in this shared editor used for note taking.
Okay.
So should we give people a minute or two to join? So I guess we can start. Welcome everybody to the TCPM meeting. We have 3 co-chairs, Yoshi, who's running the slides today, Michael Scharf, and myself. Next slide. This is the note well. I put everything on there. You have seen it in other working groups, and if you want to read it with more details using the links, you can go to the URL shown on the top of the page. Next slide. Gori is taking notes. Thank you for that. Michael is looking at the Java and relaying any input there. In case you are submitting a draft where you expect TCPM to look at, use TCPM in the name of the draft so we can find it easily using the data tracker tool. Next slide. This is the agenda. We have a packed agenda, so we have 120 minutes and we have presentations for 120 minutes. We started with the working group status, hopefully not for 15 minutes. We have presentations on 4 working group documents, the Yang one, then the 2 ECN related ones, and then RC 793 bis from Wes. And then we have a couple of individual documents, drafts, TCP accurate, we have seen that already. Timestamp extension, which is new. Then we have MPTCP presentations, ROB-E, and then two further documents for MPTCP. Then we have a short presentation on RFC 6937 BIS, which is proportional rate reduction. This is basically the beginning of this BIS process. And then the last presentation is not about a draft, but about a paper, TCP-LS. I should note, next slide. This is the status of the working group documents. We have the RTO consider, which is an auth 48, so it's done from the working group perspective. We have the RAC document, and the slide is wrong. The ISG last call was triggered, I think, an hour ago. So this is also past handling of the working group. We have RFC 793 BIS, which is or was in working group last call. So we haven't officially stopped the working group last call, but it was running, and we have an update on this document for a presentation on this. Then we have the 2140 BIS. The authors are working on it. We don't have an active draft on it. That's why it's red. We have accurate ECN and generalized ECN, where we have presentations from Bob. We have TCP EDO. We have also no active document right now, so it's with the authors. And we have HiStart++ and the Yang document. I put the milestones in parentheses, and you see it's good to make this overview, because we've figured out that we don't have a milestone for the Yang document, but we will discuss this when we come to that. I should also note that, so this is the list of current working group documents, upcoming work in the sense of BIS documents. We have also 8312 BIS, which is cubic. Work was started on that, but we haven't seen the presentation on that. I think it's up for the next meeting. And we still have on the to-do list 3465 BIS, which is ABC. We haven't seen a draft for that, but this is upcoming, so this is on the radar. Next slide. And I think it's all we have for the working group slides, right? Yep. So that would mean any agenda bashing? If you go back one slide. Lars, you want the screen? We can't hear you. We can't hear you.
How about now?
Now it's much better.
Hey, good morning from Finland. I don't want to bash the agenda. I just want to quickly point out that we've started the work. You probably saw the email to revise RFC 8312, which is cubic. There's a repo for it, and there was a -00 individual draft yesterday. There's not a ton of changes that we're planning on making. It's basically bringing the spec back in line with what Linux at least is doing, and hopefully we can hear from Windows and other implementations that they're doing also what Linux is currently doing, or we can also see if there's other changes that we might want to roll into the spec and then push to Linux. I expect us to move pretty quickly, and obviously we're going to ask for working group adoption at some point soon, which I hope will be a non-event, and this could basically be done in a couple of weeks or a couple of months. I don't think this will need a long time. So if you're interested in this, I know that a bunch of quick people are implementing cubic for the first time based on the RFC, and they've given some feedback. if you're interested in this, sort of please follow along in the GitHub repo and interact there. Thank you.
Thank you. Can you, Yoshi, can you go back one slide?
Yeah, but beforehand, I'd like to have one question.
Sure.
What's the status of the draft?
Of which draft? The cubic one?
Okay, maybe move on to the next one.
Which draft? So the status of which draft? Are you asking for the cubic one?
Yeah. So that's why I'd like to clarify, Rose.
The status at the moment is it's an individual draft, and are you asking about what, because it says standards track? Is that what you're asking?
Correctly, because the structure of the document may be changed depends on the intended status. It could be information, or it could be proposed standard.
Yeah. So I mean, the structure of the document at the moment is exactly like we had in RFC 8312, so that diffing the changes in the future is easier. I didn't want to have a long discussion about it, so I didn't say anything about it. I submitted it with a target for a standards track, simply because I think it's time Cubic became a standards track document. I know we typically don't do this for congestion control algorithms, but for this one, it kind of seems like a no-brainer. We can certainly discuss this when it comes to adoption time. I don't feel strongly about this, but I at least wanted to try and make the argument that we should do that.
Okay, thank you.
Okay, so Yoshi, can you go back one slide?
This one? Agenda?
This one, perfect. So, anyone wanting to change the agenda? If that's not the case, then we start with the Yang presentation. Mahesh, are you there? I think you are there. Yep.
Yes, I am.
And Yoshi is presenting the slides for everyone.
Okay. All right, so I will be talking about the updates to the Yang model draft since it became a workgroup document. I'm sorry, it says 00 here, but actually it means it includes 00 and 01. 00 doesn't have too many, or doesn't have any changes per se. Next slide, please. All right, as I said, 00 was the individual draft that was just the name change was made and submitted, so really no change from the individual draft. And the last one that was discussed. Next slide, please. So the updates between 00 and 01 are mostly to address the comments that we received on the mailing list. We'll talk a little bit about the include TCP options versus ignore TCP options in the next slide. Sorry, not quite ready to go to the next slide. Okay. For the accept AO mismatch versus accept key mismatch, we accepted that change and have incorporated that in the upcoming changes. And then there was a request to add the complete tree diagram for the model, which I believe we have done in the appendix of the draft. And as a process, we're supposed to have IETF copyright statements in the model, so went ahead and added that. We decided that I think the draft needed an additional reference to the keychain model as described in RFC 8177, because that is something that would be needed if anyone was trying to configure TCP AO. And then we opportunistically took the draft that Draft Touch Tcpm AO test vectors has some good examples on AO And we took that as a basis for setting up an example of how to configure TCP/AO. So that example is now also in the draft. Finally, the security considerations section has been updated to as required by RFC 8407, guidelines to the authors of Yang model drafts. And we have gone ahead and identified nodes that we believe are vulnerable for either reading, writing, or execution. Next slide. So there was some discussion on the mailing list about what to call, essentially when TCP/AO is include TCP options. So RFC 7950, which is the Yang 1.1 RFC, has the following definition for default, not definition, but it has the following description for default value of a leaf. So it's the value of the leaf, you can almost imagine it's what the server would use if the leaf did not exist in the data tree. Meaning as the data tree, what I mean, what is passed down as configuration. So if it doesn't exist, that's what the default value will be used. So with that in mind, and based on what's being discussed in the mailing list, it seems the consensus is around setting the node to default true, but keeping the name include TCP options. Now, some have suggested, well, why not just rename include TCP options itself, because the word include is a keyword in Yang, and it's used to include other models. But its meaning here is different, and in my mind, at least, it's clear. So if we do want to change it, what are the options we have in front? I think Joe mentioned options to rename it to options covered by MAC. And so we can discuss that. So I'll pause there for a minute and see if anyone has any questions before I proceed. Okay. No questions. So let's move to the, I think what's the final slide. All right. So as far as next steps are concerned, we're looking at possible implementations of the model in Linux. And if that happens, we'll present the results of that implementation in this working group. Okay, and that's pretty much it.
Thank you. Questions? So we are missing a milestone. So we adopted the document, but we missed adding a milestone to the working group. So we had some sort of discussion yesterday. So I would suggest a milestone of April next year, which allows another feedback round at the next Tcpm meet, or at the Tcpm meeting of the next IETF, and then going to working group last call. Are there comments on that milestone? If not, then we will negotiate with the AD, and thank you for the presentation. So the next is Bob. Bob has two presentations, more accurate ECN feedback in TCPM and ECN++. He has one set of slides, so Yoshi can bring that up.
Hi, can you hear me?
Perfect.
Good. Well, these slides are actually in the opposite order to the agenda, so, but yeah, we'll go straight to that one, then we'll jump to the first one. Okay, so this is a status update on more accurate ECN feedback in TCP. The draft there is 13. Next slide, please. A very quick recap. Explicit congestion notification feedback in original TCP only allowed for one or more feedback of congestion indications per round trip because that was all TCP needed at the time, but this is to allow more than one next. The sorry, next. Yep. So essentially, there's two fields in the Akka ECN protocol: a 3-bit field in the main header, repurposing 3 flag bits to make a counter after the handshake, and an option next. So activity since the last update, which was in April. You'll see there's been quite a few drafts. Sorry, you probably can't read that image at the top, but it says that in October, if you read the text, there was just some minor editorial fixes, and that reminded Michael that I hadn't dealt with the field order, which I thought I had. So I dealt with that, and also at the same time realized the reason I hadn't dealt with it was because I'd found another to-do list, my to-do list had a fork in it. So there were 2 other things which I have separate slides on, so I'll go straight to the next slide, please. Yeah, so this was what Michael wanted, to deal with the field order, which previously had the receiving implementation taking the order from the initial value, which was fragile to implement. So we've switched to a different way of doing it, which is much simpler, suggested by Michael, and that's to just use 2 option kinds, 1 for each order. You'll see here the problem is that we want to be able to use either 1, 2, or 3 fields. That's where the square brackets are there inside the fields. And so, but depending on which counter is changing, whether it's the echoing ECT0 or ECT1, depending on which one is changing more often, the implementation might want to use a different order for efficiency. So you've got ECT0 congestion is experienced in ECT1, or the other way around, ECT1 congestion experienced in ECT0. So the rest of the slide just explains the process that we went through to get to this decision. There were 2 alternatives, either 2 main alternatives, either 2 option kinds or adding a flags byte, which Ilpo proposed, and he had a use for one of the flags. I said no other proposals were forthcoming. That's Michael's pointed out that's wrong since I wrote these slides on the list. That there was one where you could have a flag, an extra byte for one of the orders and not the other, so that you could use the length field instead of the kind field. I'll come on to that. So the concern of not having a flags byte is you haven't got future extensibility. But the downside of that is that you have to burn 1 byte of option space on most packets, because you're sending this option quite frequently. And in the draft for, I think, since the beginning, but it was probably added maybe, draft 1 or something, there's been a forward compatibility which would allow you to add a flags byte by saying that the receiving implementation has to understand lengths that are not valid for the current specification, and it just reads 3-byte fields, or at least up to 3 3-byte fields, and ignores the rest. And so if you had lengths 5, 8, or 7, you would read the 3-byte fields. If you had length 6, 9, or whatever I just said, 11, in other words, 1 more byte, then you could, or in the future, the working group could define a flags byte to stick on the end of either a 1 one 3-byte field, 2-byte fields, or three 3-byte fields to allow future extensibility if we do need a flags byte, or any other extensibility we might want to. Well, not any other. You're slightly limited, but you've got a reasonable amount of flexibility just by allowing that bit of forward compatibility. So the logic of choosing the 2 option kinds means it's most efficient for now, given we have or we don't need the flags byte, but we can add one in the future. So it's sort of best of both worlds. Just to explain why we don't need a flags byte now, because ILPO proposed 1 flag bit, or 2 flag bits, to be used for a counter of which field in future you would assume was changing if you didn't get any of the fields. But the problem with that was it was designed for ACK loss, in case there was ACK loss, but it didn't allow for the fact that it itself could get lost. So it seemed a bit circular. So we don't really have any robust proposals for a flags byte. So let's leave it as the possibility of future extensibility and use 2 kinds. That was the conclusion. That's what was written up. And we can have discussion about that at the end. I'm hoping to allow time for that. Next. Right, so the other change I found on my to-do list was to add in a recommendation, not a requirement, to check that you're not getting constant congestion exposure marking on every packet, and it's written flexibly so that implementers can use future experience on what mangling is found to change things. But it says for 3 or 4 rounds, if you continually get CE marking, then disable ECN. But still feedback any you get from the other direction in case it's an asymmetric problem. All right, and that's current practice in at least 3 implementations I know of normal ECN, classic ECN. So next slide. And the final change we've made this time round, other than the odd editorial fix, is to considerably beef up the section on recommendations for middle boxes and clarify and divide it up into 4 sections, which it talked about, but it wasn't really clear what you were talking about as you went through the section. So we've put subheadings in, and there's no change to the sections on subsections on proxies and normalizers, other than putting a heading on them. And then there's more clarification on the last 2. On ACK filtering, well, actually, there's a important change on ACK filtering, not just clarification. It previously said you should not coalesce at all, but we've put a condition on that, and that is that if it's an accurate ECN packet and if the middle box that's doing it can ECN mark. The idea being here that you continue doing ACK filtering otherwise, if you're doing ACK filtering to improve the performance, like on a satellite link or any challenged upstream link. But if you're ECN marking, you're essentially giving the responsibility for doing ACK filtering to the end system, and you're giving it the information, or the network is giving it the information to do that, because accurate ECN can pick up ECN information on pure ACKs. And we will leave the specification of that, or potential congestion control of the ACK stream for the future, but we've got the mechanism now in there, and we've got a recommendation to middle boxes of how to give that information to the end systems. and that will also allow things like encryption to be used in future if you want, so that the end systems can have a way of doing ACK filtering themselves for their own performance. There's been some list discussion on this, some considerable discussion. I don't know whether Gori wants to complete that discussion because it was rather long discussion, and I think I was the last one. So if Gori wants to respond to that, please do on the list, or now if you want, if it's quick. But the essential idea is what I've just stated above, and it would allow no ACK congestion control at all, if which was Gori's concern, but it allows us to add it in the future. The next one on segmentation offload. No, sorry, not next slide. The next bullet. Go back, please. Yeah, the segmentation offload. We've just described better how incremental deployment would happen from today's practice, where if you see, or if a offload hardware sees the ECN flags change, it ejects as much of a segment as it's built from the cache, to allowing the field to change, but ejecting it before it wraps. This is the 3-bit field, and so we've described how that incremental deployment would happen. Right, next. So just now the procedural side, just to explain that accurate ECN, which is the second draft there in the middle, is now intended for proposed standard. The ECN++ draft that's experimental depends on it normatively, and they're both hanging at the moment, waiting for the allocation of ECT1 in that TSVWG draft down there, the Alpha S1, which has a milestone for next April, and the that sets up the possibility of future drafts on congestion control that could depend normatively on accurate ECN. So accurate ECN doesn't depend on anything else, but other things depend on it, is the conclusion of this slide. Next.
You're coming to an end, hopefully.
Yep, that is the end. I've said ready for working group last call. As I said, there's that conversation with Gori to complete, whether he's happy with that argument, and if not, we can make a minor changes to the text before any working group last call. And there's also a conversation that excuse me, that under the subject error in accurate ECN, where there's a possible wording change to clarify the which again is a sort of conversation that hasn't quite finished on the list, to clarify excuse me, I'm just trying to think of how to describe it briefly. The possibility that an ACK of a pure ACK, or at the moment the way the wording is stated, it looks like you've got to ACK a pure ACK. So we've just got to make that clear, without precluding possible acts of pure ACKs in the future, in a sort of keep alive type situation that I mentioned on the list, but we can deal with that on the list. And Yoshi has offered to help with that as well. Okay. So,
thank you. So, Michael,
any questions? And otherwise, yeah, I'd like to hear what the chairs believe the current status is regarding whether this would go to working group last call.
So I think Michael was first in the queue.
Yeah, hi, this is Michael speaking from the floor. Just a quick comment, since, I mean, I agree with the current content of the documents. It's pointless to argue about the alternatives. But, Bob, I think your reasoning against the length encoding is not entirely correct. And I will follow up on that on the list. And that's, to me, that's an example. You should actually have the discussion before the meeting on the list. So I will not have the discussion here for the sake of time, but I think what you just said is not entirely correct. The trade-offs with the different encodings, and it's a bit concerning to me that you have not discussed this on the list before doing edits to the document. But as I said, it belongs on the list.
Yep. Yeah, I apologize for that. That was, like I say, because I lost my to-do list, or half of my to-do list. Sorry about that.
Okay, so I'm closing the queue and Gori is next.
So my comment was yes, Bob, I would like to come back and reread the ACK filtering text and see whether it could be improved. I think we should do it in a separate thread because it got a bit complicated, and I'm willing to do that soon.
Yeah, I would agree with that. If there's more text than there needs to be in that thread.
Okay.
Okay, so this means please continue discussion on the list, and if things are resolved, we can come back to working group last, to the question related to working group last call. You have a slide regarding ECN++?
Yep.
And you
just
have 3
one
minutes
slide.
left.
Sorry, say again?
And you have 3 minutes left.
Okay. It's very easy. We just refreshed this draft. There's been no changes. It's just waiting in a holding pattern for the accurate ECN draft. There were just minor changes. That's it. You have 2 minutes for discussion if you want on maybe on what the status of both these is regarding working group last call.
Thank you. Is Gori still in the queue, or did you never? You didn't know. Yeah, I guess since the ECN++ is referring to the more accurate one, and the more accurate one needs some discussion on the mailing list, I would say we wait until the more accurate is finished before starting a working group last call on the general last call.
Yep, thank you. That's reasonable.
Okay, thank you for the presentation. If there are no questions, then we move on to 793 bis, Wes.
Okay, and can you hear me?
Perfect.
All right. So we have been working on updating RFC 793 for a while, and there was a working group last fall some time ago. A few sets of comments came in, and the revision that's posted now, revision 19, addresses most of those comments. The small number that are left dangling are itemized here. And I'm planning on trying to drive these to closure in the near term by starting a thread on each of them and proposing a path forward. I think that none of them are huge compatibility issues. They're mainly just questions of what we want the messaging to be in this document. So to go through them really quickly in case they give anyone strong ideas about what we should do. There's a question on how we phrase the fact that options must have a length field. It's really a matter of big must or little must. So I think we just need to find specific wording that people can agree on there. There's also a suggestion to use a capital should for some of the commonly used options, that to say that they should be supported in implementations, and that would be regarding timestamps, window scaling, and SAC. I think that's a good suggestion, and I think it's in the spirit of things we've done previously, like in the TCP roadmap. So I think it's probably okay, but I would definitely like to hear if there's more working group support for that, or if there's any pushback, because it is slightly, I would say, outside of our scope of not changing anything that the standards track documents say should be done in a TCP implementation, which was sort of the ground rule going in on this document when we started that work. Same thing actually true for the next two bullets, which are SYN timeouts having a requirement of 3 minutes. Praveen suggested that that is a large number, and well, that's, I guess, hard to argue against. It's also true that changing that is sort of outside the scope that we chartered this document for. So I would really like to hear if anyone else has thoughts on that. And additionally, I think there's a good suggestion that we should say that RFC 5681 congestion control is a sort of baseline that must be supported, but that, of course, other algorithms can be supported as they are in common implementations, and those can be optionally enabled. So these are the kinds of things that we're still trying to finalize. I plan to start a thread on each of them to get them taken care of. But of course, if you have any thoughts on them during the meeting here, please feel free to shout them out. I would like to. I have two more charts, and then maybe we'll come back to this one if anyone wants to say anything. So I'll go to the next chart, which is a plan for next steps. So get closure on the items previously mentioned. I want to update the draft however we agree, and also work a little bit more on the changes from RFC 793 section. And then I think this revision 20 that will be posted should be ready to go forward, unless there's some reason to keep the working group last call open for even longer. Either way is fine with me, but I would think that it's getting ready for AD review, or for the working group Shepherd review at least. If you go to the next chart, I just wanted to briefly acknowledge the huge number of people that have been contributing to this over the years. I think the activity level is hard to see because we've been working on it so long, and sort of individuals contribute in spurts over the years. But this has actually been quite a number of people have contributed to this over the years, and I just wanted to acknowledge that here. So that's all I have. I think there's a couple people in the queue, and if you want to go back to the first chart, I would welcome any input on those questions.
Thank you. Bob.
Yeah, it was just a feedback on the last point about 5681 from Praveen. I was just thinking, if it's a challenge device and say it's implemented CoAP or something similar, I'm not quite sure why you would want to say it's got to have the baseline in it as well. That seems like a just purely implementation choice, not a something that should go in an RFC.
Okay.
Martin, you're next.
Can you hear me?
Yes.
Yeah, similar to Bob's comment, I think it's a little odd to say that you must implement 5681, that we would say that a TCP implementation that just jumps straight into cubic or something would be wrong somehow. I'm not sure what the right language is. I'll think about it a little bit, and when you start that thread, maybe I'll have something better.
Yeah, so I think the source of this is 1122 actually says that sort of Reno is the you must implement for congestion control. And we have never changed that over the years, although we've adjusted and incremented the description of Reno from what 1122 had through 2581 and 5681 over the years. I don't think anything changed the 1122 requirement. That is the sort of basis.
I mean, it is true that we don't have a ton of standards in this area, although I guess Lars is doing his best to fix that. Okay, well, I'll think about it some more, and when you send the email, maybe I'll have
Yeah, maybe some kind of
less
standard
instant reaction.
control is the right way to say it.
Jana. If you're saying something, we can't hear you. We can see you, but we can't hear you. At least I can't hear you.
Can you hear me now?
Yes.
Ah, okay. Magic. I just had to toggle it again. So just very quickly, I don't have a good suggestion on the text here, but I would strongly recommend in general that we move away from trying to standardize these things in the TCP RFC at least. Be very much. It's a question really of whether we want to hang on to something that we written down like 30 years ago, or we want to reflect what common practice is these days. And for all practical purposes, almost nobody uses Reno, widely speaking. So we should consider that. Republishing something with just text because it's already there, I think I would argue is not the most sensible thing.
Okay, thank you.
Bob, are you still in queue or? The answer is no. Anyone else? Gary. Gary? Ooh, at least I can't hear you if you're saying something. Martin?
That worked this time. Great. Yeah, just I would like to support John's remarks, and this would be challenging to word, and maybe this is opening can of worms. But like in a perfect world, I think this document would describe in some way the characteristics of what we would want in a congestion control, and we could offer examples. But do we have a document today that really kind of puts out the expectations of a new congestion control and kind of the things that the qualities it needs to have to sort of be judged to be friendly? It's probably too large of a thing to put in this draft, but if there's something succinct we can say in that area that maybe falls short of an actual full spec, that would be valuable.
I'm actually thinking the right thing to do is to say an IETF standards track congestion control is what must be included, and others can be included at an implementer's Will.
I like that.
Sounds good to me too. Jana? And I'm closing the queue after Jana.
I would gently push back against that. Again, for the same reason. I don't see a reason to require an IT standard congestion controller when nobody's going to follow that requirement. Now, we're requiring because we want to be consistent with our document set, or are we trying to reflect reality here? We certainly be consistent with our own document set if that's what we want to try and do. I would try to move away from that. Martin Duke's question is a good one, and that's something that we actually tried to chase for the quick loss reduction and congestion control draft. And unfortunately, there isn't a good set of common principles or a document that says, okay, here's what a congestion controller ought to have as its properties. But just because we don't have that doesn't mean that we cite the one algorithm that we have and require it, even though we know nobody's going to really care about that. So I mean, I'd be personally comfortable with in the document saying that you need some sort of congestion controller, and it's that we have one in 5681, and there are other alternative ones. As we can point to Cubic if we want, and we can even point to something that's not an RFC form. BBR is used commonly these days, and despite what we think about it, it is being commonly used. So I think that there's value in being able to simply say that it is reasonable to consider other controllers and not require 5681.
Thank you. So there's work to do on 793 bis. Thank you, Wes.
Thank you.
And Yoshi, I'm not sure. I see a screen share is being shared, but I don't see any slides. So next up is TCP rate request from Charles.
Hello, can you hear me?
Yes.
Okay. Hello, everyone. My name is Carlos Gomez. I'm going to present the updated version of the draft entitled TCP ACK rate request option, TAR option. Next, please. First of all, a reminder of the motivation for this draft. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead. However, it may also contribute to suboptimal performance in some scenarios. We have identified two sets of such scenarios in terms of the congestion window size in use. The first one being so-called large congestion window scenarios, meaning congestion window size much greater than the MSS, and the other one, so-called small congestion window scenarios, meaning congestion window size up to the order of 1 MSS. So in the first set, large congestion window scenarios, saving up to 1 of every 2 ACKs, which is what we can get with delayed ACKs, may be insufficient, for example, to mitigate performance limitations due to symmetric path capacity, or if we want to reduce the computational cost of the sender, receiver, and network load of having too many ACKs. And in the small congestion window scenarios, for example, we have data centers where the bandwidth delay product may be up to the order of 1 MSS. So in that case, delayed ACKs will incur a delay much greater than the RTT, therefore possibly degrading performance severely. And also in transactional data exchanges or when the congestion window has decreased, eliciting immediate ACKs may help avoid idle times and may help allow faster congestion window growth. Next, please. So on the status of the draft, there was some prior discussion before the initial version of the draft in the area of sender control of TCP ACKs, which converts to defining a new TCP option serving two purposes, allowing a TCP sender to request a given ACK rate or to request an immediate ACK from a receiver. The initial version was presented in the last IETF, and today I'm presenting 01, which aims to address the comments received in the last IETF. By the way, thanks to everyone who gave comments, which have been very valuable. And also we added some explanation on how a TCP endpoint announces support of this option. Next, please. So about the updates in -01, the first update is in section 1. This is intended to address a comment by Stuart Cheshire, where now we have expanded the motivation for the need to use immediate acts in some IoT environments. There are some IoT devices with really constrained memory with enough RAM only for a send buffer of 1 MSS. So in that case, due to delayed acts, a sender may need to wait for the delayed act timeout and receive and process the act to be able to transmit the next data segment. And this has been given as a reason sometimes for not using TCP in some IoT scenarios. Then in section 3, there are 2 new features that were actually suggested in the last IETF, which have been added to this option. The first one was a suggestion by Jana, by which TCP sender, in this case, can indicate that it has some reordering tolerance by setting a new field in this option, which we call ignore order here. And in that case, the TCP receiver must continue to send one ACK every hour data segments, even when reordering occurs. By the way, here we have used the same name for the field as in the draft that Jana pointed to, which is a draft in the context of the QUIC protocol. We use the same name to somehow minimize confusion there, but if this is inappropriate, just please let us know. And the second new feature added to the option is was actually a suggestion by Gori. So here, TCP sender can request now an immediate ACK for a data segment and also for the subsequent N data segments. Thanks again for the suggestions. And next, please. So this would be the updated option format, which now includes 2 new fields which correspond to the 2 new features mentioned in the previous slide. The first field is the ignore order field, which is a 1 byte field, which is Boolean. It may be set to true or false. And the next field is N, which indicates the number of subsequent data segments for which we are requesting immediate ACKs when R is set to 0. So here there's a question that may be answered maybe today or on the list, depending on available time, which is that perhaps we might want to consider to save 1 byte, for example, thinking about IoT environments where every single byte is relevant. So we might want to reduce the size of the R field from 8 bits to 7 bits and perhaps use the remaining 1 bit as the ignore order field, therefore reducing the total size of the option from 7 bytes to 6 bytes. Next, please. And the other update in the draft is that now we explain that a TCP endpoint announces that it supports the TAR option by including the option format in packets with a SYN bit set. However, well, in that case, the R, ignore order, and N fields would be ignored. And there would be perhaps an alternative, which could be using a dedicated short 4-byte format without the R, ignore order, and N fields, but perhaps using a second code point dedicated just to announce this support. So, well, that's perhaps another alternative that we might consider. So that is actually all from my side. So I don't know if there may be comments or questions.
Thank you. Jonathan?
Yes, I have. I read this through this morning, and something like question 1 occurred to me just on reading that. But what I noticed was that the ignore order field and the N field are mutually exclusive. based on the value of R. So they could be overlaid on the same byte.
Okay. Yeah, that's an interesting alternative that yeah, we hadn't thought about. So yeah, thanks for bringing this up. So yeah, let's analyze this as well.
Richard, and I'm closing the queue after Richard. Richard, I can't hear you if you're saying something. Richard? Okay, so you got some feedback, Charles.
Yeah.
And I would say just continue the discussion on the list. And thanks for the presentation.
Okay, thank you.
So next is Kevin on extensible timestamps.
Hi, can you hear me?
Yes.
Hi, this is Kevin. I'm going to present this TCP ETS for extensible timestamp options. Next slide, please. So we designed this new option called ETS in order to subsume the RFC 73223, the original timestamp, and in this option we exchange the maximum ACK delay in the handshake. We propose to use a finer clock granularity, that is 1 microsecond per timestamp tick, and we introduce an echo reply delay for measure the network RTT, and this option will allow us to use NIC hardware timestamp for better network RTT measurement. Next slide, please. So the motivation for this option first is for doing congestion control. So we want to precisely measure the network or host delay for accurate and precise network RTT that can enable us for simple, effective data center congestion control algorithms, especially aided by NIC hardware timestamping. For example, in the Swift paper published in CCOM, it is using the hardware timestamp to compute the RTT that is traversed through the network and use that as a signal to congestion control. The second motivation is we want to have a mechanism in loss recovery to have a better minimum RTO estimation. So in the legacy implementation, the minimum RTO is set to 200 milliseconds, which might be too long. And the third motivation here is to improve the pacing rate computation. As we compute the pacing rate by k times congestion window divided by smoothed RTT, and this SRTT is measured by the RTT that includes the delay X. So it will bloat it hugely, say 100 times than the network RTT. Next slide, please. The existing problem in the RFC 7323 timestamp option is that the delay from the delayed ACK are included in the RTT measurement, and the RTT can only be measured only if the ACK advanced the SND, the UNA, which is the left edge of the sending window. And host side delays are included in this RTT measurement. For example, in the network, the CPU can sleep and wake up in an RTT in a round trip, and this waking up delay will be measured in the RTT, and we can observe that in data center network, this CPU waking up time can be longer than the network RTT. And another problem is the clock frequency is too coarse versus the modern data center network usually with RTT less than 100 microseconds. Next slide, please. So in this proposed new ETS option, we use an EXID. The TS val and TS ECR have the same semantics in the original RFC, but they are in microsecond unit. And we include ECR delay. And we specify the unit of this ECR delay. So this ECR delay can be in microseconds or milliseconds, but its unit is specified in this option. And then we include max ACK delay, but this last field, max ACK delay, only presented in the handshake, in the same package. So in the regular data package followed by the handshake, it will not have this max ACK delay. Next slide, please. So here is the example in the handshake. So we will include ECR delay in all packets, but only include max ACK delay in the handshake. Next slide, please. So here is how we compute this ECR delay. The ECR delay can be computed by this algorithm. So we will have TS the latest and TS the latest clock be the arrival time of the segment that with the latest TS value. And when sending a packet, we will calculate the TS ECR to be TS recent as defined in the original RFC, and the latest ACK delay to be the sending time of this segment minus the TS the latest clock, and the TS ECR age equals to TS the latest minus the TS ECR. And then this ECR delay equals to the summation of two components, which is the latest ACK delay plus the TS ECR age. So in the next, I will show two examples demonstrates how we compute these two components and what's the meaning of these two components. Also note that ECR delay is 0 when there's no ACK delay and the TS-ECR is the latest received timestamp. Next, please. So here is the example we showed how we compute the network RTT. So first, the network RTT is defined by the time from when the data segment leaves the sender until when it arrived at the receiver, plus the time from when the corresponding ACK leaves the data receiver until the ACK received the data sender. So in the example here, TCP-A at time 1 send a packet to TCP, and the ACK is delayed, and at time equals to 10, the TCP will ACK a packet back. So in the ACK, it will have TS-ECR equals to 1 echo in the TS value, and the ECR delay is 8, which is computed by the calculation on the right. So we have the green color marked to the latest ACK delay. That is the time from when the ACK is sent to the time this data packet is received. So it's 10 minus 2, which is 8. So when the TCP-A received this ACK, it can compute this network RTT by 11, which is the arrival time of this ACK, minus 1, which is the TS-ECR, minus ECR delay, which is 8. So it will get the RTT to be 2, which is the time that this packet travels through the network. Next, please.
Please leave some time for questions.
Okay, sure. How many minutes do I have?
3.
Okay. So here's another example shows that we use the ACK ECR delay to compute the network RTT when the ACK is ACKing 2 packets. So the TCP-A send the first packet that is delayed, the ACK is delayed, and then send another packet at time 5. It arrives TCP-B at time 6, and then TCP-B send the ACK back. So in this ACK, it has ECR to be 1, and ECR delay is to be 4, which is computed by the equation on the right. Here the TS-ECR age is from T1 to T5, so it is 4. And then when the sender receives this ACK, it can compute this network RTT to be 7, which is the arrival time minus 1 minus 4. So this is the RTT of P1 prime, which is the second packet. Next slide, please.
Can you
Okay,
come to an end?
Yeah, so I guess this the second last slide before discussion. So we also exchanged the maximum ACK delay in the SIM package during the handshake. So this maximum ACK delay can be used to bind in the minimum RTO, which will be useful for computing the RTO timer. Yeah. Next slide, please. So in the discussion, I will quick discuss some interaction with pause check. So this required that we disable the pause check if the connection is idle for, say, half an hour. And if your detection algorithm will stay the same. And retransmission timeout, we don't, it's not affected, so it is using the same mechanism. And this option will left space for 3 SAC blocks. Next slide, please.
Please come to an end.
Yeah, middle box security, we don't add new security. So for future extension, can be appended at the end of this option. I think that's it. Q&A. Any question, comments?
Thank you. Richard.
So can you hear me now?
Yes, I can hear you, and I'm closing the line after Praveen.
Just very quick, I would
Please
really
quick.
need the SYN option to be really much more space efficient. And for ideas how to do this, I would like to refer to the TCPM timestamp negotiation draft that I've had a couple years ago. And also, I believe this mustn't need to be an exclusive dedicated option. It could be an extension of 7323 and just differentiated by the length field again. Thank you.
Thank you. Bob, you're next.
I'll just say +1 because that was nearly exactly what I was going to say. The point is
Thank
the
you.
timestamp. Yep.
Vidi? Vidi, are you saying something?
Me now?
Yes. Yes.
Sorry, probably my mic had a problem. So I was saying this is good work, and delayed ACK should be considered during the calculation of retransmission timeout, and the draft, or at least the slides mentioned that those would not be affected by this change or this new addition in the timestamp. So I was wondering, what is the target use case for calculating the network RTT? I have one in mind, but I would like to know what the author were thinking about the use case for this.
It is mainly used for the control.
Exactly, yeah. So Leadbad is one of them, and I have been recently seeing some problems with delayed delayed ACKs, and the RTT gets really inflated when the network RTT is actually not. So definitely this is something I would look into. Thank you.
Thank you. Praveen, you're next and last.
Yeah, great work. So I think Vidi, can you mute?
I can hear you. We have an echo,
yeah,
so.
Yeah, the max ACK delay is actually a really useful thing. It just solves the min-RTO problem in the data center, so I think that's very, very useful. I'm not very convinced about coupling that with timestamps, but I will continue to review this draft. One question I have is, are you considering to publish this as experimental, or are you planning to request like a formal option type of this?
Yeah, we are requesting for a formal option kind after we get an RFC.
Okay, so we have to stop here. We have 5 minutes behind the schedule, so I think next is MPTCP Rob E.
Hello, Marcus speaking. Can you hear me?
Yes.
Very good.
If you can be shorter than 10 minutes, that would be perfect.
I will give my best. So I want to give you an update to the multi-pass TCP robust session establishment we proposed some IETFs ago. That's some joint work and presentation from Jiao and colleagues from Huawei and myself. Next slide, please. So just a short recap. So multi-pass TCP robust establishment is a set of extensions to regular MPTCP. We do not distinguish between the old MPTCP RFC 6824 and the newer one. We support both. The idea is to design a robust establishment process for MPTCP sessions, which is not given by the aforementioned RFCs. We propose several mechanisms that the Robi timer, which uses the retransmission timer, TCP retransmission timer to probe subsequent paths. We have the Robi SIM and eSIM. Both are firing simultaneously the handshake process on all available paths. And last but not least, we have the Robi IPS, which makes some smart decisions on which path is the best one to start the initial handshake process. Next slide, please. So what has been done so far? As I said, it was presented some IETFs ago. It was an IETF 106 where we presented it the first time. For 107, then we prepared a hackathon contribution. Unfortunately, that has not happened due to COVID-19. Nevertheless, everything we planned for the hackathon, then we presented in IETF 108. So we performed all the things we prepared for the hackathon, and we tried to do there offline, and we presented the results then, as I said, in 108, and these results were very promising and presented that there is a benefit of applying robust establishment to multi-pass TCP. Next slide, please. Last time at IETF 108, we requested adoption. However, there were some concerns from the Tcpm chairs in respect to IPR. I think we made some clarifications in the meantime on that. Please follow the links in this presentation to see what we updated there. And there was another concern from the Tcpm chairs that we shall include the multi-pass TCP experts into the development of the draft, and I think we did this. Can you please go to the next slide? So here you will find the link to the discussion we started. So far, we have not received any objections. However, there was some feedback from Olivier in respect to load balancer. I think we gave some answers or some guidelines to this in a sense that we conclude that robust establishment is something optional, so it has not to be applied. It can be selected by sender and probably also by receiver. So in case of load balancers, I fully agree that would be an issue, but load balancers has not to select or has not to support robust establishment. It's more something which I see either to be end-to-end applied, or maybe in such cases where we have multi-pass TCP proxies, as it is, for example, in 3GPP 80SSS. The next iteration of the draft we plan for IETF 110. And again, I want to put the question here, can we jointly adopt the draft document?
So thank you. So you said you clarified the IPR declaration. At least when I looked at it, there's no statement about the license, except for it's fair and equal, and
exactly that the current status.
Yeah. Okay. So it's my understanding. It's something which is, so you're making no statement about if it's possible to include it in an open source implementation.
That is a good point. To be honest, I think Huawei is currently discussing this internally to make their code open source. So far, there is no result from this internal discussion, but maybe Jiao can jump in if there are some updates. So I think she is part here of this session.
Depending on the time, I would say get that to the mailing list.
Okay.
Anyone? Lars, be quick.
I'm very quick.
Possible for you.
Hi. Yes. So if you guys open source your code, that's great. But I think the question is actually whether other people can implement the specification given the licensing declaration in open source without the need to get a license from you. I think that's the question.
Yep.
Okay. So is that the only hurdle you see to getting adopted, or is there something else?
Does anyone else have an opinion on this? On adopting? Lars?
For me, this is sort of necessary, right? That we get over that before we can even, like. There's no point in adopting something that you need a license to implement. So
okay.
Once we settled that, I'm willing to have a further discussion.
Okay, yeah, because then we lose probably some time if and I would like to do things in parallel if possible. So if there are other hurdles seen from your side, we could work on getting them around in the meantime when we clarify the IPR stuff.
So I think the IPR stuff is kind of a central thing, taking that a lot of TCP implementations are in the kernel provided by OS vendors, and some of the OSs are open source, like Linux or FreeBSD or other stuff. Okay.
Thank you. Yeah.
Thanks for the presentation. Next is accurate data scheduling by server and MPTCP.
Hello.
Hi.
This is okay. This slide is a status report about the work on accurate data scheduling by server in MPTCP. In fact, we have submitted a new version for this draft. Next. Yeah. This page lists the changes since last meeting. We have submitted a new version, and we update some description of the use case. Update the definition of the MP navigation option, and from the mail list discussion, data scheduling on client when receiving MP navigation will be considered later. The last one is security. Will be considered later because we want to analyze the possibility whether this option will be abused by our attacker. And the list paragraph lists the key points. If I understand right, in the TCP mail list discussion, they said what are advantages comparing to current MP priority option, and also how about this scheduling on client when client and the server have conflicting or different strategies, And next is how to implement such kind of logic. Last one is this should be also our input for MP quick. Yeah, this is all that I can collect from the mail list discussion. Okay, let's go to next page. I update the description about the use case. As you can see in the pictures, the server have multiple and 4 address, and this addresses belongs to 2 operators. For scenario 1, that is server have a tool, he can detect the performance of each network interface. When they found that the KPI of one network interface is not better than before, he will change the traffic from this one to another one that with better KPI. And for scenario 2 is that a new network interface be added during a MP TCP session, and the server want to one requirement is for test. They want to change some traffic to the new one for test the network interface. And scenario 3 is just for operation requirement that for the service owner, he want to provide his VIP user with subflow that with better KPI, better performance. The last one is that the MPTCP server hope to adjust the traffic based on the changes in the network cost. This 4 scenarios is what we found for the requirement. Okay, let's go to next page. This is the definition for these options that you can send from server to client to inform server requirement to the client. I think the JS ID is used to identify the target network interface that the server want to traffic to. Okay, let's go to the next page. That's the plan for our work. We think data scheduling on client when receive MP navigation will be considered. We will consider it in details about how to implement it, and important is the security problem. And we are planning to arrange a demo for it if required. In fact, we have a F1 developer. He is also the co-author of this draft. He told me that if this draft is available to Tcpm group and the demo is required, he can put some time on this work. Because of the some uncontrolled effects, so we cannot promise the timeline for this demo. But if required, we can discuss with our team. Yeah, that's all for the draft.
Thank you. Other questions or comments? I guess Lars is in the queue, but he just didn't leave last time.
Okay.
Or am I wrong? No. Okay, so no comments here. You have another presentation on fault management, right?
Oh, yes. Yeah.
Okay,
This is
go ahead.
Okay, this is also a new idea for MPTCP. It's also from our operation requirement that we want enhancement in current fault management. We have submitted the draft to Tcpm group. Okay, next page. Yeah. This have described the use case for why we need enhancement on MPTP fault management. As you can see in the picture, there are multiple paths between client 1, client 2, and the server. when two parts are encounter the problems, this problem will cause the parts cannot be used for data transmission. You mean that the problem is happened suddenly. So we can use other parts to transfer the problem of this RAM subflows to the server. You can as shown by the green arrows, and the server can collect all the RAM info, and he can use the info from multiple clients to determine which node is wrong on the path. Yeah, this is the key idea for the. So okay, let's go to next page. This is the flow for the solution. During MP TCP session, there are multiple subflows, and the client determined that one ongoing subflow is 40, and this 40 is suddenly. So, how he can determine this problem? Maybe a client can have a tool. He can listen to the board. He can detect the problems. And another way, he can receive the report from a third-party tool on the network, and the tool can report the problem of the network to the client, and the client can determine the cause, and he can send the faulty reason to the server. Why another subflow that's running well, and the server can receive these options. Next page. We define a new option that called faulty announcement option, and this option have the main changes to current to this main changes to this option is that we define a course and destination address ID and the source address ID. The course, we know that there is a reason have defined in a current MTCP protocol. If it can reduce, we can add some new values to this field. And the destination address ID and the source address ID is used to identify the faulty subflows to the server. That's all our suggestion for the option. Next page. I think, that's all our suggestion. Adding comments are welcome. Yeah.
Yeah, are there comments or questions? Yoshi.
Can you hear me?
Yes.
Yeah, I can. Yes.
Okay, so I have one live question on this draft. Yeah, so when something happens on the subflow, then even client side can receive something like a reset packet or ICMP packet, or it could be timeout. And then, so I would like to understand the use case that this approach can be useful.
I think this info is used because the server can use this info to determine depending on the path which node is faulty. Yeah. I mean that maybe from one client. From one client, it cannot determine the location, but from multiple clients, if we will all report that the subflow over the one machine is wrong, I think the server can use to determine the pushing. Yeah, this is the operating requirement.
Yeah, to some extent I understand, but maybe you can clarify in your draft in the next version.
Yeah, yes, I will do it if, yeah.
Thank you. Any other comments? Okay, then thank you for the presentation.
Thank
and
you.
Next up is Matt, and we can see him. Go ahead. We can see you, but we can't hear you. Say something?
Is that good level?
Yes, now it's okay.
Okay. It's good to be speaking to the IETF again. It's been a couple of years. I'm here today to ask to bring proportional rate reduction in as a work item for TCPM to bring it to proposed standard. Next slide. Just to recap PRR, the idea, the primary function of PRR is to control essentially congestion control during recovery, determining how much data to send to smoothly go from the old in-flight down to the new SS thresh. It's fairly straightforward and it's widely deployed. The interesting part of it is what happens when there is more loss, when there is loss which takes the flight size down below the target SS thresh. And that during that case, it sends data more aggressively than it was receiving ACKs. And this is all described in the current document, 6937. And PRR is currently used everywhere by all congestion controls in Linux. Next slide. By all estimations, a vast majority of the web traffic is PRR. Somebody told me that they thought 50%. I think it's actually considerably more than that, given the high volume of the operating systems listed there. There have been no changes to the algorithms that were in the original document. However, in 2015, one of the sources of the situation where PRR, the slow start reduction bound, was discovered to cause excess losses was identified, and that is policers that suddenly changed their rate by a very large step, a larger step than the CC congestion control change. The consequence of this is you get into a state where, say, the path went from 10 megabits to a token rate of 1 megabit. The congestion control picked some reasonable rate like 5 or 7 megabits, and the network drops every 9 out of 10 or 7 out of 10 or 4 out of 5 packets. And the congestion control had no warning what the new rate was, and both of the algorithms in the current RFC don't handle it very well. In 2015, there was a heuristic discovered that lets you dynamically switch between the two algorithms, and the consequence behaves much better than either algorithm by itself. So, next slide. We'd like to introduce it as a work item. I don't think it'll take very long. I'm hoping 2 IETFs, but sometimes these things have a long tail. I can imagine getting most of the way through this for the next IETF, and then follow up on some loose things. As one of the authors of 6937, rereading it later, it's much, much too verbose, and it's annoying to read, and I would like to make it, if I'd had more time, I would have made it shorter, as they say, and focus on what implementers need to know. And a lot of the prior results and the prior explanations are available in the existing document, and can be included by non-normative reference, so because it's non-standard. So, any questions? Short.
Any questions? Any comments supporting this work? Or... Richard.
So can you hear me?
Yes.
Yep.
I like this work. I like to make this proposed standard. looking into the heuristics, and I wanted to update your list. FreeBSD is now also doing PRR, but not by default. You have to explicitly enable it. It's been included a couple of weeks ago.
Cool. Thank you.
Jonathan.
Yes. You said that it is only active during fast recovery. What about when dealing with an ECN mark?
So the Linux ECN implementation has a state they call CWR, congestion window reduction, which normally takes one round trip and uses PRR. It's exactly parallel to recovery.
Right. So
I'm actually not familiar with how that code matches against the standards.
Right. I think it might be worth addressing that in the new version.
I figure some ECN discussions will come up, and it should be
okay.
It should be more specific, but it's out of scope for us to make major specifications of ECN that aren't already baked someplace else.
Praveen, you're up next.
Supportive of this work as proposed standard. I have one question. So the 2015 problem observed with policers, is there recent data to suggest that that is still a problem?
Yes. I know that people are very aware of, now that we've seen policers are very aware of the consequences of policers in the network. It would be nice to eradicate them, but there's some older hardware that's sort of the default way of doing traffic management. And as it moves out, especially into the Southern Hemisphere, it's still very prevalent.
Jana? Jana, if you're saying something, we can't hear you. We can see you.
You can't hear me?
Now we can hear you.
Ah, okay. Wow. Okay. So this
magic.
We'll finally get this right someday. Thank you for bringing this up here, and I'd be supportive of moving this forward. PRR has been used quite extensively. One thing to note is 6937 even says that PRR is a form of soft pacing. I wanted to ask if anyone has documented or has looked into the interaction between PRR and pacing. I think that will be worth some text going forward, given that a lot of implementations and a lot of deployments are using pacing by default these days. It would be important to consider what both the value of PRR in the face of pacing and also the interaction between pacing and PRR would be.
That's a good point. Thinking about it, there's a sort of a complicated piece which has to do with how do you manage the timestamps, the scheduled times on the packets for the pacing, and that's the kind of thing that the IETF hasn't specified very well. Doesn't normally specify as an implementation detail, but it matters a lot for the answer to your question.
I think it matters a lot in terms of how people think about deploying both pacing and PRR.
Yes, and for instance, when we run I'm sorry. there's some complicated state changes between when you're paced and when you're window controlled, and they bother me too, quite frankly.
Yep. I'd be interested in understanding the value proposition of PRR if I was to have pacing. Like, my understanding is generally that if you have pacing, PRR shouldn't really be adding too much value.
I
But
would
I'd like
agree
to
with
hear
that.
what do you think about that.
But we've also encountered some environments where window control is absolutely the right way to go. For instance, the data center. And so you need PRR in the data center. It makes a difference in the data center.
Let me explain a little bit about pacing and PR. Think of PR as when you get the X, PR will try to release some amount of traffic sort of at the some ratio of the amount that's been delivered, right? What the ACK would indicate. So typically in the normal cases, you get an ACK of 2 packets or 1 packet, which then you release those. But in the case when you actually get some kind of ACK compression during fast recovery or ACK thinning due to middle boxes, you could have actually released, say, 10 packets, 15 packets into the network because and then this kind of burst will have to be handled by the, say, Linux pacing, which will break up this burst based on the current pacing rate. And the pacing rate, at least say in the cubic model, is still based on C1 divided by the RTT. So that's sort of the relationship between PRR and pacing. So PR is still ACK clocked, but in case of when the ACK is being thin or compressed, you still need sort of a more fine granularity pacing to break up the burst. So that's the way to think about PR and pacing.
So I'm closing the line after.
Thank you. Sorry, if could I get in there quickly?
Sure. Yeah.
Oh, thank you. I completely agree with that. ACK thinning is the one I was thinking about, which actually was I think for me the question was, given that I will need pacing to deal with all of those conditions anyways, what does PRR offer to me as if I've already deployed pacing, what does it offer in addition? That was my question, Yuchen.
Sure, that's clear up in the subsequent text update. Yeah.
Mm-hmm.
Okay, so I heard support for work or TCPM working on this. So we need to get this on the mailing list and discuss it between the chairs. You can think about a potential milestone, a realistic milestone. You think this could be finished because we need to add a milestone if we adopt this. Okay.
Sounds good.
Okay, thank you. This brings us to the
you.
last presentation. Olivier, are you there? I guess. Yes. So this is about a paper, TCP LS.
Yes, so this is TCP/LS. This is a joint work with Florentin Rocher and Emery Asogba from UC Louvain. Next slide. So if we look at what's happening with TCP and TLS is that both protocols are often used together, especially in the WAN, and TLS provides security, and TCP provides connection abstraction, reliability, congestion control, and it's still the most popular transport protocol today. And if we look at what's happening on the wide area networks, it's very likely that TCP and TLS could always be used together. Next slide. So let's go back to TCP. And in TCP, when TCP was designed, we have a very simple separation between the control channel and the data channel in TCP. So the control channel is part of the TCP header with a TCP option, which has a restricted length, and the data is part of the payload of the TCP segment. Next slide. Now, let's look at TLS 1.3 and a quick summary in one slide. In TLS 1.3, you have a secure handshake where the client sends the client hello message, which can contain some options as an extension field. The server replies with a server hello, which also contains some options that are encrypted. It provides the finished message, and it can also include some application data. And then the client concludes with the finished message. All this information can be placed inside the payload of the SYN packets if you want to do 0 RTT with TLS 1.3. And then, sorry, once you have established the TLS handshake, you can exchange TLS records. And what's nice in TLS 1.3 is that all the TLS records, they appeared in the payload as of type 23. And the real type of the TLS record is encoded in the encrypted and authenticated field as a true type, which is the last byte of the TLS record. Which means that all the TLS information that you send from middle boxes is always application level data type 23 for TLS 1.3. Next slide. So what we could do is that we could integrate TLS and TCP closely together. So we could use TLS record to carry TCP control information. And in fact, what's possible is that we could have two control channels for TCP, one which is the regular TCP options, and a second one which is using encrypted TLS records. Next slide. So we have two control channels, one in the TCP header and another one on the TLS record, which gives us lots of extensibility and unlimited space to exchange TCP options in the TLS records. Next slide. So let's look at some things that we could do by closely integrating TCP and TLS. And I have a few examples, but you probably have other ideas. So first example is securing multipath TCP. When we designed multipath TCP, we decided to put a token in the SYNAC, which is the key, which is exchanged in clear. And then we had issues with authenticating ad address and making ad address reliable. If you want to do that with TCP-LS, you could use the TLS handshake and the secrets which is negotiated during the TLS handshake and derive a multipath TCP key from this information, which would be secure. And you could use TLS records to exchange the ad address option, which makes the ad address option both reliable and authenticated. And we could still keep remove address as a regular TCP option because it needs to be sent without reliability. Next slide. Another example is TFO. In TFO, we have a TFO option, which uses small size cookies to exchange and to validate the client. Using TCP-LS, we could use TLS0 RTT and encode information in the client hello and in the server hello, which would allow us to use cookies that are much larger than the current TFO option. Obviously, using longer information in the payload of the SYN and of the SYN plus ACK could create some issues with middle boxes, but if you look at the measurements that Christophe from Apple mentioned a few years ago, he showed that it doesn't seem that TFO is blocked by the presence of long payload in the SYN or the SYN-ACK, but it's more the TCP options that creates problems with middle boxes. Next slide. Another example is that with TCP-LS, we would have more space for TCP options since TCP options could be part of a new type of TLS record. And we have already implemented that in the TCP-LS prototype. So you could exchange a TCP option during the handshake. So for example, the server hello can provide an additional option in the SYN-ACK with the encrypted extension. We can define a TLS record to carry TCP option, and we have done that for the user timeout option, which is not supported by Linux, but we can put this user timeout option in TCP-LS, and then when the client or the server receives the TLS record that contains the user timeout option, then it can do the set socket option. It's also possible to do a late negotiation of the TCP extensions using TCP-LS. Next slide. We could have TLS records that are used to encode TCP keep alives that allow to check whether a TCP connection is still alive by just sending dummy data inside TLS records, and you have a kind of new ping-pong TCP-LS record, which is not part of the data. Next slide. You can do secure connection release by having a new type of TLS record that marks the end of the TCP-LS session and which cannot be caused by middle boxes, which cannot be sent by middle boxes. Next slide. You can do IP eyeballs by having the server provide its alternate IPv4 or IPv6 address in the server hello encrypted extension. So this information is encrypted and authenticated. And so the client learns the alternate address of the server, and it can try to create the TCP connection over the IPv4 if it started over IPv6. Next slide. Another interesting point is to do connection migration. So you can do with TCP/LS connection migration as you do it using Quick today. So you have a smartphone that wants to move from cellular to Wi-Fi or the opposite while preserving the established TCP/LS session. And the solution that we have implemented right now in the TCP/LS prototype is that the server provides a connection identifier and a cookie in the server hello message, which is encrypted. And then based on this information, the client can create a TCP/LS subflow to the server using that information, and the server matches the subflow to the previously established TCP/LS connection. And then the server and the client can move the data transfer to the new subflow when there is an event. So in the example, you see that the client and the server are connected to a 30 megabits per second link. The client receives IPv4 and IPv6 addresses from the server, and it starts over IPv4, and after some time it decides to switch to IPv6, and the connection continues without any problem for the application. Next slide. So to conclude, this was a heads up to show you that TCP and TLS should not always be considered as separate and independent protocols. And there are many benefits that can be obtained by coupling these two protocols together, and it's possible to efficiently combine them together. There are more details in the paper, and there is a running code which is based on Pico TLS. And if you have ideas on things that you would like to do with TCP/LS, please contact us, and we would be happy to discuss with you.
Thank you for the presentation. Jana.
Thanks, Olivier. I'm assuming I can be heard.
Yes.
So how does this work with proxies that terminate the TCP connection but not the TLS connection?
So
HTTP connection mind, but there's a lot of middle boxes that do this as well, where they terminate the TCP connection, but they'll just they'll forward the bytes that are in the TCP connection along to the next hop.
But then the TCP options that are sent in the TCP header won't work, but the TCP options that you would send in the TLS would work. And it's also, with this solution, it's also possible to detect these kind of proxies, because you could take the TCP segment that you sent, you put it in a TLS record and you encrypt it. And so on the server side, you check that the TCP segment that was sent by the client is the same that was received by the server. So you could have the sequence number, the TCP options.
I get that.
So you can detect the presence of a proxy. Yeah.
Right. No, I get that. And what I'm saying is it's not to detect the presence of a proxy, but the negotiation. So if I send the options that I am trying to negotiate with my TCP peer, and I send them via TLS, it goes to, let's say it goes to the next. So if say it's two segmented connections like this, right? And I'm trying to negotiate with my peer, but I end up negotiating this with that endpoint. Now this end thinks that it's speaking those options with, I don't know how to explain this without a picture, but I'm negotiating TCP options with a peer with whom I'm not speaking TCP. Does that make sense?
Yes.
So what does that mean in terms of what we just negotiated?
So
let's say I negotiate SAC through this.
So I can detect that I have a proxy, and I can stop using the TCP/LS TCP options in the TLS record, because there is a proxy on the path.
Right. I'm saying that you would have to. Otherwise, basically,
we can
you
do
don't
that.
have. Yeah.
So you can check that. So you could exchange, for example, the TCP sequence numbers in a TLS record to check that you have the same values of the TCP sequence numbers for the SYN and the SYNAC, for example. And then based on that, you can detect whether you have a proxy on the path, or you can do more advanced heuristics to detect that there is a proxy on the path. And if there is a TCP proxy on the path, then you have issues because you don't terminate the connection correctly. But we can detect that efficiently.
Right.
Just a note, we are over time, and I think we are kicked out in a minute. So, Yoshi, you have whatever time is left.
Okay. So thanks for presenting a very interesting idea. I like reading your paper. And then, so one naive question I have is this technology contains a lot of stuff. It has similar features to TCP crypt. It has similar feature for MPTCP. So if you proceed this idea, it can be replacement of MPTCP, or it can be a replacement of TCP crypt. So, and then I'm basically wondering how do you want to proceed this idea in IETF? And especially if this seems to be too big for Tcpm working group, in my understanding.
Yes, so first our objective is to understand what are the real use case where coupling the two would provide most of the benefit, and then to develop running code and to extend the running code so that we can do experiments. And once we have running code and we know that the solution works, then we can come to the IETF and bring the ideas to the IETF. But I think what's important now is that if within Tcpm you are blocked by the difficulty of exchanging TCP options or exchanging TCP options that would need to be reliable, maybe think that if your use case involves TLS anyway, then you could use TLS as a way to exchange the reliable TCP option that you would like to exchange.
I see. That means you want to limit some features to some extent at first.
So we will need to prioritize, and we will need to see where there is most of the benefit by coupling the two together. And there are parts where there is no benefit. So for example, doing SAC, it's not possible to do SAC with TCP/LS, but for MPTCP, you can do add address and you can simplify the exchange of the keys. So there is a benefit for MPTCP. There are other benefits that you could do. So we are discussing congestion control and things like that. You might know that congestion control now it can be implemented using eBPF on Linux. So it's possible with this approach to exchange the eBPF congestion control scheme over a TCP/LS connection. So the server could send a different congestion control scheme to the client to adapt the client to the current networking conditions, because you can encode the eBPF code that contains the congestion controller inside TLS records that are sent by the server. So there are lots of opportunities by coupling the two together.
Okay, thank you.
Thank you.
Thank you very much for this interesting presentation. I think this concludes this TCPM session. Thank you for participating and joining, and see you at the next IETF. Bye.